So far we are done with the basics of object-oriented programming in Python. We have seen how to define a class, how to go for the constructor. Then we have seen instance variable. We have seen class variable. Then we have seen how to define the methods in the class, how to define a class method, how to define a static method. And we have also seen that how to define a single constructor in such a way that it is capable of getting called in multiple ways as a default constructor, as a parameterized constructor, and also as a copy constructor. So all those things we have seen. Then we have also seen inheritance, that how to have an inheritance in a Python program, how to inherit the properties and the methods of one class into another class. Then there are different types of inheritances. So we have seen all these basics of object-oriented programming in Python. Then as a part of a module for that, one topic is remaining, which is exception handling. So that we'll be discussing in the next session. And meanwhile, what we'll be doing, we'll be talking about a few advanced data structures in Python. Now, these advanced data structures in Python are basically the data structures which we have already studied, like your stack, then your queue, linked list, fine. So what we'll be doing, we'll be seeing that in Python, how these data structures are handled, whether the data structures are handled using the available data structure in Python, or we have some other the library through which we implement this advanced data structure. Okay, so today we'll be doing that. Okay, so let's go for the new one. We call it session 9 or 10. Stack, queue, and linked list. Now we all know what do you mean by stack. So I hope each one of you knows what is stack, what is queue, what is linked list. So let me know what is stack. Yes, please. You can either unmute your mic and say, or you can just post your answer into the chat box. Yes, come on. And let me know the different operations that can be performed on a stack. So Zaki says first in, last out. Any other student? What is stack? Come on. Storage of elements in LIFO system. Okay. Same thing, last in, first out. It is a linear data structure in which insertion is done from one end and deletion is done from another end. How come, Farhan, deletion is done from another end? You have two open ends in stack. Then Hari says stack is a linear data structure in which elements are inserted from one end and it follows last in, first out. Same end, yes. So a stack is a linear data structure in which insertion and deletion are done from the same end. So you have only one end open into the stack, and from that end only you insert the data and you remove the data. So the story is simple. Whatever is inserted last, that would be deleted first. Okay, because there is only one end open. So there are no two ends, only one end open. So from single end, the data is inserted and data is removed. So when the data is inserted and removed from the same end, so it means that whatever is inserted last, but obvious that would be deleted first. Then there are different operations onto the stack which we have seen. The most basic operations are you can insert the data onto the stack, and that is called as push. You can delete the data from the stack, that is called pop. So these are the most basic two operations on stack. And then apart from these operations, there are a number of operations which you can implement depending upon the language in which you are implementing the data structure. So what we'll be doing, we'll be implementing the stack using list. It is a very efficient way of implementing a stack using list. We'll see how. So let's define a main function. Let's do a very structured or a modular style of programming instead of just putting your code straight away. So I will be having my stack as a object of a list class. So stack becomes the object of a list class. And then I can keep on inserting a data into the stack. So which function of a list class can be used here to insert the data or to push the data onto the stack? Please let me know. Come on. Which function I can use? Append. Very good. Why append? Why not insert? Because in stack, conceptually, you have only one open end. So when you have only one open end, so the idea is to insert the data from that end only and delete the data from that end only. So when we append the data, okay, and then for deleting the data, if we use the pop function of the list class, so it will be befitting our requirement of the stack, because the insertion would be done at the end and the deletion would also be done at the end. Okay. So in the list, when you append the data is inserted at the end. And when you pop the data from the list using the pop function, so the data is removed from the end only. Okay. So that satisfies the definition or the requirement of the stack. Whatever is inserted last, that would be deleted first, LIFO structure. What I can do here, I can simply say that for insertion, use append method of list class, and for the deletion, use pop method of list class. So if I want to append anything into my stack, or I want to push anything into my stack, so what I can do, I can simply push it like this. Suppose I am having a stack of numbers. So first I insert 10, then I insert 20, and then I push 30. And then for popping, when I say stack.pop, again stack.pop, I'm performing two pop operations. And then here I would be saying if the name of my module equals to main, then only call my main method. Okay, so let's execute this code. Let's see the output. sorry. We need to print this. So yes, what we can see here, the first data which got removed is 30, and then the next data which got removed is 20. And if you see the sequence of inserting a data or pushing a data, so first we pushed 10, then we pushed 20, so 20 came on top of 10, and then we pushed 30, so 30 came on top of 20. So when we start popping, so we got 30 first, then we got 20, and then if I perform one more pop operation, so it would be 30 and then 20 and then 10. If I try to have one more pop after this, what would happen? Can you tell me? Come on fast. Let me know your answer before I execute this code. I have inserted 3 data elements into my stack. I have pushed 3 data elements in my stack, and I am performing pop 4 times. So for the first 3 times, it would give me the data, but what would happen at the end for this 4th pop operation? Come on, let me know your answer. What would happen for this last pop? What would be the output? Yes, please. None. Aditi says none. Then Daniel says list is empty, list is empty. That would be the output. None would be the output, and then list is empty would be the output. Any other problem? You are trying to pop from a list which does not have anything. So you are trying to pop from a stack which does not have anything. So when the stack does not have anything, whether it would return none or it would display list is empty, or what would be the output? Error will occur, list is empty. Now Daniel says error will occur. Let's see what happens. I'm executing it. So see what happened. It says then stack.pop, and for this it says indentation error, unexpected indent. This should not happen. Now we are getting a correct error. First 30 is popped, okay, fine. Then 20 is popped, okay, fine. Then 10 is also popped, okay, fine. Then after 10, when our stack is empty and still we are trying to pop something, so what happens? See, now here comes trace back. And this trace back throws us some error, some exception. And the explanation of the exception is pop from empty list. And the name of the exception is index error. I repeat, the name of the exception is an index error. So here we are getting an exception. So the exception is a runtime error which is thrown when something goes wrong during the execution of your code, during the running of your code. So when anything goes wrong during the execution of the code, we are given an error, and that error is called as an exception. Okay. So the last line gives us the name of the exception. The name of the exception is index error. All these exceptions in Python are implemented in the form of classes. I repeat, all these exceptions in Python are implemented in the form of classes. It means that this index error is a name of a class. I repeat, index error is the name of a class, one exception class, and the name of that exception class is index error. And this exception is thrown whenever we try to access the data element into a container or into a collection which uh, where we are trying to go out of index, something going out of index. So there the error is index error because there is nothing into our stack. Our stack is completely empty and we are trying to pop something from the stack. Okay. So the explanation of the error is pop from empty stack. So in short or in a nutshell, an exception will be thrown for this fourth pop operation. An exception will be thrown, and the name of the exception is index error. Now, after inserting the data into my stack, at any point of time, if I want to see the content of my stack, I'm simply writing here the name of my list or the name of my stack, and I'm printing it. So this is my stack. So this is at the bottom, this is the next element, and this is the topmost element. Okay. You need to read the stack in this way. And then the topmost element is popped first, and then the next topmost, and then the last element. Now, the same thing you can do in the form of a function. So you can write a function to do all this stuff. What I have done, I have kept it very simple. Inside the main function itself, I am appending the data, and directly I am calling the pop function. The idea is what? Since there is already a method called append to insert the data, so why to write any other function? And then inside that function calling the same function. What I mean to say, we can simply write a function. For example, something like this, say push, and here I would be sending the element to be pushed, and then also the stack in which I want to push the data. Then I would simply say ht dot append, and going to do this. Push. Then the first one is stack. Second one is my element. Say it is 40. Let's see. So see here 10, 20, 30, 40. And then the first element which is removed is 40. Next one is 30. And then you have 10, 20. Sorry. Now there can be few questions into the mind like we are then passing the address of a stack. Then also the stack which we are passing is getting appended. So this is not a new stack. This is the past stack. So these are basically the references. Okay. So since these are the references, these objects are the references. So when you write the object name itself, so basically a reference is passed. So using that reference, it gets modified. So I hope you understand it very well. So what I wanted to say that see if I implement a push function, so I can simply implement a push function like this. But inside this push function, we are calling the append method of the list class. So since you are calling the append method of a list class over here, the same you can do here itself in your main method or in your main function itself. Okay. So either way you can do, it's up to you. How do you want to implement it? But as I have shown you, you can implement it in both the ways. You can directly make use of the append method of a list class, or you can encapsulate that append method inside your own function. So here we have our own function push, and then inside that function we are calling the append method. So it's up to us how do you want to uh, push, or how do you want to implement the push and the pop methods or the operations. Okay, I hope you are understanding this, and this is how you can push a data into the stack. This is how you can simply print the data of the stack, and this is how you can you can simply pop the data from the stack. Now, here you can see that the data is displayed like this. And if you want to display it in the reverse order, if you want to first display the topmost element and then and so on, so that can also be done. You can make use of looping for that. So for example, I say for I in, let's try, then no, stack, start from the length. I want to go up to 0, so I would be saying -1, and I want to decrease, so -1. Just let me see and print, and I say stack of I. List index out of range. Okay, it should be -1, sorry. Okay, so our stack got displayed like this. If you see here, 40, 30, 20, 10. Okay, so this is how you can display the stack elements if you want to display it from the topmost element and go to the bottom of a stack. So how did I do that? For the I in range, and my range start from the length of stack -1. The range starts from, see here carefully, the range starts from length of my stack -1. So if there are 4 elements into my stack, so the length of my stack is 4, and it should be, the start value should be 4 -1, that is 3, because the indexing starts from 0. Okay, so 0 is the first element index, then 1, then 2, then 3. So 3 is the index of the fourth element. Fine. So we'll be saying length of stack -1. This is my initial value. And then this is my end value. Means up to this I should go. If the end value is 9, so it would go up to 8. If the end value is 10, so it would go up to 9. Likewise, if the end value is -1, so it would go up to 0. I am starting from the index of the last element and I want to come up to 0. Okay. So I would be giving here the final value as -1 so that it would come up to 0. And then my step value is -1 because I want to decrease. I'm starting from a positive value, or I'm starting from a number, say 3, 4, 5, and I want to come towards 0. I want to decrease for every iteration. I want to decrease it by 1. That's why my step value is -1. Okay. So this would display, this for loop would display the content of a stack the way you want, from the topmost element to the bottommost element. So yes, this is how you can implement the display function. Or if you say, so I can write here display function where we pass the stack, and I put the for loop over there. Stack contents. And here we call the display function for our stack. Okay, so stack content, and this is our stack content. Stack content 40, 30, 20, 10. And these are the popped element. So here also you can display it properly as per your choice. So this is how you can make use of list to implement the stack in Python. And likewise, when you talk about queue, so what happens for queue? For queue, you have two ends. And from one end, you insert the data, and from another end, you delete the data. Okay. So in this case, whatever is inserted first, that is deleted first. So this is first in, first out data structure. A queue is a first in, first out data structure. Now, if I want to implement a queue using list, so what can be done? I can make use of a append method. Okay, fine, absolutely fine. No issue for that because the insertion is done from their end. So I can make use of the append method for inserting a data into a queue. But when we say about deleting a data from the front end, okay, so there, if you make use of a pop method of a list class, so you need to provide the index. Okay, let's do that and let's see how that can be done. So this is my stack, and after my stack, suppose I go for the queue. And I say queue equals to list. It is also an object of a list class. And for inserting, I make use of append. So I insert 10, and then I insert 20, and then I insert 30 in my queue. So 3 elements I have inserted in my queue, and if I display the content of my queue, let's see the output. What do we get? So this is our queue, and it says 10, 20, 30. Okay, so the data is inserted properly in a queue, no issue with that. Now, when we try to delete a data from the queue, as I said you, what we'll be doing, we'll be making use of the pop method. And here, there is one possibility that if you do not pass any argument to the pop method, by default, it will be popping the last element. And then there is one possibility that you can pass an index value. So if you want to specifically delete any element, or you want to specifically pop an element from the list, so you can provide the index value of that element. Now in queue, we know that the deletion is done from the front end always. So it means that the element at the 0th index would be deleted first. I repeat, the element at the 0th index would be deleted first. So what we'll be doing, we'll be passing a index value 0 to the pop method. And if I print this, let's see what output we get. So yes, the queue elements are 10, 20, 30. 10 was inserted first, then 20, and then 30. And then when we deleted the element, so first element got deleted, that is 10. Okay. So now 10 got deleted because we have provided the index value 0 for the pop method. And now if I display the content of my queue, see here, it is 20 and 30. Now what's happening that we need to understand very carefully. First, the 10 got deleted. In case of stack, when we were popping the element, we were popping the element from the end, or you can say from the top of a queue or from the top of a stack, and we were inserting the data. But when you talk about queue, what is happening? We are inserting the data from the end, but we are deleting the data from the front. Okay. So if you see here, you got three elements 10, 20, 30. And when you popped the first element, that is 10, your 10 is popped. And then after that, the queue content is 20 and 30. You know what's happening over here? Here, when 10 is popped, so basically you can say that 20 and 30 got shifted by one position. 20 and 30 got shifted by one position. What I simply mean to say you that there is a difference between pop and pop 0. So what I do here, I write here itself. There is a difference between calling the pop method like this and then calling the pop method like this. And there's a big difference that you need to understand. When you simply call the pop method without passing any value, it simply deletes the last. Okay, no more additional work. But when you delete an element by calling the pop method and by sending or by passing an index value, which is not the index of the last element. So in that case, when that element is deleted, all the elements to the right of that element are shifted left by one position. I repeat, all the elements to the right of that element are shifted left by one position. Okay. So it means that this pop 0 is costlier than pop in terms of computation time. I repeat, pop 0 is costlier than pop in terms of computation time. Okay. So my next line would be pop 0 is costly as compared to pop. And costly in terms of what? In terms of computation time. Let me write here. Costly in terms of computation time. Okay. Costly in terms of computation time as compared to pop. So now, what is the option? The option is that if you implement a queue with the help of list, so there will be always this problem, because the definition of the queue says that first in, first out. Whatever is inserted first, that would be deleted first. Right? Now to get rid of this problem, there is an additional library in Python called a dequeue. So we can make use of that library to efficiently use the queue data structure. Repeat, to efficiently use the queue data structure, we can make use of that library, which is available in Python. Okay. So what we'll be doing, we'll be making use of that library. So I will be saying that from collections import dequeue. See carefully what I'm writing. From collections is a package or a module, you can say. Better if you call it module, we are importing dequeue, and dequeue is a class. Okay. So here comes the definition of dequeue. It's a class. So DQ is a class, and we are implementing that class from the module collections. Okay, so collections is the name of a module. This module implements specialized container data types, providing alternatives to Python's general purpose built-in container, dictionary, list, set, and tuple. Okay, so here you have the implementation for the queue and efficient implementation for the queue. Okay, I repeat, an efficient implementation for the queue, because in a queue, when you delete the data, so basically you delete the data from the front end and you insert the data from the rear end. So you need some efficient way of doing this instead of the way list is implemented. So when you pop the zeroth index element from the list, all the elements to the right of that element would be left shifted by one position. So this becomes a costly. Okay. So to get rid of this, we make use of. So let me say Q is an object of a DQ. And then to insert the data, we can make use of Q dot append as it is. And then I insert 10. And then I insert 20. And then I insert 30. Okay. And then I just go for the printing of this queue. So it says a DQ, and then it displays the data 10, 20, 30 like this. And if I want to display the elements, if I want to display it element by element, so that I can do with the help of looping. Now, how to delete the data? I got the object Q dot and I say pop. So if you see here, there are two variants of pop. Okay, and it's a DQ. What is DQ? Double-ended queue. What is DQ? Double-ended queue. So can you tell me what is double-ended queue? Come on, fast. Why it does have the two pop methods implementation? It has pop and then it has pop left, because it's an object of a DQ, not of a queue. But then we can make use of a DQ object as a queue. It's up to us how we are using it, how we are exploiting it. Come on, fast. Please let me know, why do we have two pop methods over here? One is the pop, which would be popping the last element for sure. And next one is the pop left, which would be popping the first element from the left side. So pop is simply pop right, something like that. And pop left is the leftmost element would be popped. So please let me know, why do we have two pop methods for the DQ class? Please post your answer or unmute your mic and say the answer. As DQ is double-ended. Absolutely right. Elements can be deleted from both them. Yes, you're absolutely right. It's a DQ, double-ended queue. Double-ended queue means the data can be inserted from either end and the data can be deleted from either end. Okay. So if I want to delete the data from the right end, I can make use of pop method. If I want to delete the data from the left end, then I can make use of pop left. I want to make use of a pop left method. See here. So the first element was 10, and then this 10 got popped or it got removed. And now if I display the content of my queue. So now the 10 has been removed, and now you got 20 and 30. Okay. If I simply make use of pop, so it would have removed 30. But now I'm making use of pop left, and so it has removed the first element 10. So this is how you can implement a queue using a DQ. And this is a better approach as compared to making use of a list. List is good for implementing stack, but for queue, it is better to go with a DQ. And when we are going with a DQ, we know that a DQ is double-ended queue, so the data can be inserted from either end and the data can be deleted from either end. But we want to make use of that as a simple queue rather than a DQ. So what we'll be doing, we'll be making use of its append method for inserting the data, and we'll be making use of it, making use of its set method for deleting the data. I repeat, append method to insert the data into the queue, and pop left method to delete the data from the queue. Okay, I hope the things are clear. So this is the implementation of stack and queue in Python. And for your kind revision, stack is implemented using a list very well without any issue. But when we implement a queue using a list, computation time issue. It takes a lot of time for making use of the pop method of a list, because we need to pop the first element. So we'll be calling the pop method as pop of 0, and pop of 0 is costly in terms of computation time as compared to pop. Okay. So for that purpose, we will be importing a DQ, and we import DQ from collections. And once you import the DQ, then you simply declare the object of a DQ, and then you make use of a append method for inserting a data into the queue, and you make use of a pop left method to delete the data from a queue. And for displaying a queue, you can simply print a queue, or you can loop into the queue, or you can iterate into into a queue, and you display the queue elements one by one. So it's up to you how do you want to implement it. So about list, we'll be doing it in the next session. Any query from your side, please let me know. I stop the recording now.